All right, hello everybody. I just want to go over real quick some of the different concepts that are in chapter 10 that we may or may not have gone over in lecture and or that might be a little bit more challenging. This one is one of two that we're going to go over that involve changes, so initial and final information. The gas So this particular question asks, what happens to the pressure when a temperature changes? So in order to do this type of a problem, first thing we want to do is go through and identify the information. So we have initial pressure and initial temperature. We also have a final temperature. So putting that together, we have initial and final information. One of the things that we want to do is we want to identify that since we're going to be using the ideal gas law, because that makes the most sense, the volume and number of moles of gas will not change according to this equation. So in other words, we just have to come up with a relationship that only connects pressure and temperature. And so what we can do is we can actually say that P over T will equal NR over V. And this number is going to be constant. And so what we're going to do is we're going to use this P over T relationship because those are the two things that are changing. And we're going to say that initial will equal final information because the ratio has to be the same. From there, we're going to plug in our information, and this is just one of the two ways that you'll be analyzing how changes on pressure or changes on temperature can happen. Now, what we can do is if we have two pressures and we want to find a temperature, all we need is an initial temperature. Or if we want to find the final temperature, if we want to find the final pressure, we can use 3 of the 4 variables. So this relation is very important. From there, we're going to plug and chug. Solving for pressure 2 because 1 always indicates initial in these equations and 2 always indicates final in these equations. Solving for pressure 2, we plug in our numbers. And remember that when we plug in temperatures, we always have to convert them to Kelvin. So they went ahead and they did that for us. We find that the second pressure should be 3.6 atm. Okay, another version of this type of initial final situation involves the effect of changing pressure and temperature on gas volume. So again, we're going to use our ideal gas equation, and we're going to note that temperature and N is constant. So we can rearrange the ideal gas equation so that PV and T are on one side, and then N times R would be on the other side, and that's going to be constant. And so the relationship that we're using here says that initial pressure volume divided by temperature is going to be equal to final pressure volume divided by temperature because they are ratios. As one changes, the other should have the same types of changes. It just may change different variables. Temperatures got converted to Kelvin. Pressures are in atmospheres and volume is in liters, just like it's supposed to be. So from there, we're going to go ahead and we're going to plug in everything we know to solve for our second volume or our final volume. Rearranging and solving, we just get that this is going to be 11 liters. So really what I want you to take away from this is we can use a relation like this to calculate initial or final information, and we can use the relation from the previous problem, just relating P and T. We could also use one where it said P1V1 equals P2V2 to identify changes in initial and final situations. And those are the 3 major ones that you would see. The last thing I want to discuss is just the van der Waals equation, which we've seen before in our lecture, where things are identified based on their identity. Here we have Cl2 is the gas that we're going to be dealing with. So the A and B values are going to come from a table, and they're specific to Cl2. And then we have other information that we're given. We're given the pressure, we're given the volume, and we're given a temperature. All of that information is going to come together so that we can use the van der Waals equation. And since we're trying to solve for a pressure, we want to rearrange the van der Waals equation, which is this one over here, and we want to rearrange it to solve for pressure. And so doing that gets us this particular result. And then from there, we plug in everything we know. Remember that R is 0.08206, it's a constant, and then everything else needs to have their units converted if necessary. So for instance, our temperature needs to be converted from 0 degrees Celsius to 273 Kelvin. Our volume should be in liters. Our N number of moles should be in moles, not grams. And then to solve for pressure, our pressure should then end in atmospheres. And so plugging in all of our known numbers, we get the value of 0.990 atm. Now, we would expect this to be 1 atmosphere. That was the first sentence we were given. The correction tells us it's slightly lower. And that is what the van der Waals equation is there for. It's going to correct the ideal gas equation for what's really happening to a specific gas. Now, remember, A and B are always going to be tabulated values for different substances. If the substance is not on here, you would have to be given the A and B values for you to actually correct a specific pressure or to correct whatever you might be correcting. If I wanted you to calculate volume, you could. It would be kind of a pain in the butt, but for the most part, the van der Waals equation is usually used to correct pressures only. Okay, all right, and that's all for this one. Now you should have everything you need to go ahead and work on your practice problems, which are up on Canvas they are in your OneNote notebook. Okay, and there's 3 of them. One for each of the ones we just went over, and I would like them done by the end of the day today. I will be checking all of the practice problems by the end of the week, so please make sure at the very least that they are done by Friday. Okay, you have a great day. I miss you all.